experience around it. So now we come down to some of the core principles of scaling a general system. So the first principle that we traditionally apply is what we call partition by function. So if you are an SOA enthusiast, you probably know what I'm talking about. I mean, this is not something new. It's even when you build a single monolithic code, you try to make it more modular. But with systems that are a lot more decoupled, you try to build subservices or subsystems that you can scale independently. So any system, I mean, most of the system by design should be loosely coupled. Any tight coupling will introduce dependencies that you might find it very difficult to walk away from it. So you have to be very careful when you build your systems that they tend to be loosely coupled. And I mean, this is something, it's kind of an irony as well, but this is kind of a tight line to walk, right? So you are actually breaking a huge monolithic system into multiple subsystems that you can scale up individually. But then managing the interaction becomes a little bit tricky, and then you have to build a lot of software abstractions around it. So, I mean, if checkout is just one huge monolithic app, yeah, it's great, all complexities within it, but you'll just not be able to scale, you'll just not be able to honor that number of checkouts that you do today in a cost-effective fashion. But then you start saying, okay, this will be the user service, this will be the inventory service, that will be the orchestration layer, this will be the billing service. Yes, there is a lot of interaction that happens between these services. So you push the complexity a little bit into the interaction, how these systems interact. So you give up on the simplicity of being a monolithic app, but then you can scale in individual subsystems, right? So for example, if you are a fulfillment system and then or a settlement system and then the pay system, on the pay system you can be very elastic during the day, and then your settlement systems can be a lot more elastic during the night. So that's when you settle a lot of transactions. So it's like you can scale the settlement system separately, you can add more nodes, or make it more elastic during the night, or bring down the elasticity of those services during the day, right? But then your transaction services are up and running, picking up during the day. But you need that kind of partition, otherwise you have to scale the monolithic app, and it won't be cost effective. So partition by function, whatever you call it, function decomposition, SOA, we do it at the code level all the time, jars, packages, bundles, etc. But that's a guiding principle that you have to follow. And there is nothing like a single solution to all this. You figure out as you go through. So if you're trying to do too much in a service, yeah, you probably are very coarse. You probably have to change the granularity of your service. Or if you're just doing too little, also you have to figure out, is it like really worth being a service or not? Whether can I live with a static library? So all this you have to make a call, and there's nothing like a formula to all this. Sometimes you just have to go through real pain of going through production systems, get your ass kicked, and then you realize, okay, maybe I was doing too much on that. It needs to be separated out. The other thing that you have to be aware of is just because the JVM supports a lot of threading, etc., you shouldn't be like initiating a lot of threads per request. And the reason is, any thread, I mean, if you're doing a lot of IOs for a request, it also takes up the socket space, it takes network, etc. So most of your app tier is probably doing a lot of this logic and opening a lot of socket connections. So if you're trying to do a lot of parallel threads, it consumes the system resources. So in a sense, you are blocking other requests from being done within the SLA. Same thing on concurrency as well. So you need to make a call, like there should be parallelism because otherwise it's very difficult for you to maintain your SLA. But that doesn't mean you just start killing other requests, or consuming so much that other requests are not able to be placed on that particular node. Same thing on concurrency, right? So if you're trying to do too much of like when your subsystem is trying to talk to the transaction system or the settlement system and the invoice system, etc., and you need data from all that, you should probably look at your system. Is that the right data model? Why am I doing so much low level locking, and that too across so many domains that probably should not be talking to each other, right? So when you're doing concurrency, it's good to have a concurrent paradigm, but it comes with a grain of salt. So you have to, again, there is nothing like a silver bullet to all this, right? So there's no single formula. You have to go through, you have to look at your system, you have to look at the SLAs, and then what you're doing, try to figure out what the best approach is. And what goes without saying in all this is, decentralized. There should not be a single point of failure. So even when it comes to development, right? So there should not be a single point of failure. So anything that you think will take the whole system down, will make the system basically not available, you should walk away from it. So you should figure out what's the best way to decentralize. So on the next thing is everything is local. So all state that you know is local. So a given system can talk to multiple subsystems, or is talking to multiple systems upstream, downstream, or in a parallel fashion. But all your data, all your state data is local. So if I'm building an inventory system, it's like I should not be depending on the cart system being available all the time. So if it's available, good and great. So because if a user is adding an item to the cart, okay, as an inventory system, yes, I need to know that so that I can place an order with my vendor to get that cart into my warehouse, right? Or if I'm a settlement system, yes, so if I know if a particular transaction is going through now, I can settle it quickly. But I shouldn't be worried about if the transaction system goes down, that's fine. So I should still be able to do settlement for transactions that I know of. So if you are in the business of trying to figure out what is the state of this particular entity is in a different system, it leads to a lot of chattiness and systems will be down. So it's like you are not able to do your work because somebody else is down. So all state is local. So you have to make sure this you don't do a lot of trying to figure out this logic based on somebody else's state. Whatever business logic you do, whatever logic you do, is purely on the state that you know of as it is. You are the system of truth. And you should have the ability to handle failures locally. So systems, as I said, other subsystems might be down. For example, if a user buys, if a user buys a diaper, a user buys a baby toy, there's a good chance the user is going to buy some other baby-oriented material. And you want to publish that to, say, the recommendation engine or the user recommendation engine, right? But that system could be down. So that doesn't mean you don't fulfill your duty of fulfilling that particular transaction. You probably do an internal queue or separate wait for that system to come back up. But you go through your action as if it's like you're blind for like the horse in the race, right? So you just go through in your track, and then act as if systems will come back up again and they will figure out a way to get the data. So what we call, this is an interesting paradigm, what we call separate promise from action paradigm. So even if you know your own database is down, like if your system of record is down, but you still end up getting a request, you try to go through the request. You see, okay, the request is good to go, but unfortunately my database is down, but I'm still going to cache this. So I'm going to put it in a, some kind of mem cache or whatever internal caches you have. You try to put that in and say, okay, or you have an abstracted internal queue, so that you still are to an interacting client, you are still up and running. But then internally, you actually know, okay, I can do this only for a while. It depends on my cache capacity, etc. But then you can still go on, like you can still take 20 gig of requests because you have internal caching for 20 gig. And you hope by that time your database is up and running where you can dump this 20 gig and then you're done, right? So there are ways to build these type of abstractions out, where even when your system of record is down, you can still act as if everything is good. Eventually, that is. And the other thing that when you go through, this is kind of tied to a couple of previous slides. So what you realize is your caching. It depends on what type of caching you do, but you have to figure out anything that gives you a better hit rate, right? So if that means you're choosing one stack versus another stack, etc., one memcache versus something else, you have to make the call. But then, whatever you need to have good caching, so that your cache ratio is high, and also you don't cache high velocity write change data. I mean that's not going to work anyway. So when you cache, you just have to make sure it's mostly read only. It kind of goes without saying, but then when you do your system breakdown, you realize you do some of these things that are kind of fundamental, but then it kind of falls through the cracks. So it's very important that you have proper caching in place, proper DB caching, or whatever cache that it's appropriate to